So we're continuing on with law of sines. The reason why is there's an exception with law of sines. There's a possibility that with the law of sines we can have 0, 1, or 2 triangles that exist. And I'm going to show you how to use the law of sines to solve these different triangles. Now, back when you were in geometry, you were probably told that there was no such case as a angle side-side or side-side angle case. That's not true. It just has a lot of different possibilities. And today we're going to go ahead and talk about those different possibilities and what happens with a side-side angle case. So there's a decision tree kind of here. And you're going to be given, obviously, two sides and an angle. And you'll have a pair, so angle A with side A. So it should look like you should be able to do law of sines. Now the issue is not every set of data that you're going to be given here will make an actual triangle. So if A is acute, less than 90, then we're dealing with this situation over here. And we have 4 different possibilities. If A is less than H, and what is H? H is B times the sine of A. That's this height here. It's the same kind of height that we use to find area of a triangle with the sine. So it's B sine A, so the other side sine times the sine of A. When we do that, if that value is, if A here is less than that value, then there's actually no triangle, because what happens here is, if you notice, if we have a small a, it never can reach down. It kind of like dangles. And so you have your B, you have your angle, and this height here is too much for this a to touch the other side. And so because of that, there's actually no triangle that is formed. If it is exactly the same, then we have a right triangle, and we have 90 degrees, and it's really easy to go ahead and solve that one. Now, if it's bigger than H, but smaller than B, so A is bigger than H, but less than B, so bigger than H and smaller than B, we actually have a situation where we have 2 triangles. We have one obtuse triangle and one acute triangle. And we'll have to be able to find both of those, and I'll show you that in just a minute. If A is bigger than B, it can't swing back and form this other side, so it has to go ahead and be just one solution. So there's 2 one solutions, a no solution, and 2 solutions. And all of it has to deal with compared to what H is. Now, if it's right or obtuse, that's real simple. If A is less than B, then it's no solution. If A is greater than, then it's one solution. So that one's a lot easier if it's right or obtuse. But if it's acute, there's 4 different possibilities depending upon how A compares to H. All right, so let's go ahead and look at some of these. Let's determine whether or not we have 1, 2, or no solutions. To solve this triangle, we're going to go ahead and, again, we have our pair, our Q with Q here. And so that's what we're going to go ahead and start comparing. But we have to go ahead and find that H value. And what that H value, again, remember, is the other side, the 8 times the sine of 110. So we're going to have to do that. So 8 times the sine of 110, I'm sorry, we don't have to do it because we're talking about an obtuse triangle here. When we're talking about obtuse, we're into this section here. So when it's obtuse, we're only going to compare A with B. If A is smaller, there's no solution. If A is bigger, there's 1. So this A value is bigger, so there is 1 triangle. So we know that there's 1 solution. Now, once we know that there's 1 solution, we can just go ahead and do this like we did yesterday. And we go ahead and find the other side, other angle by going ahead and cross multiplying. We're going to have to do a second sine here. So the sine of n equals 8 times the sine of 110 divided by 11. That's 0.6834. And then we have to do second, the sine -1, the second sine function. And we get 43. Well, once we have the one side being 43, then we can go ahead and find the other side, which will then be 27. And once it's 27, we can do cross multiplying to find the last side, which is 5.3. And there you have your whole triangle. All right, What about this one? So this one, we do have an acute, so now we have to deal with the 4 different possibilities. So we need to find out what this h value is. Now again, this is 9 times the sine of 52 is this h. So 9 times the sine of 52 is right here, and the 9 times is 7.1. So now we're going to compare this 5 to that 7.1. Well, 5 is less than 7.1, so that figures into that first situation where there's no solution. All right, here's another one. We have acute again, so we're going to do 15 sine of 28. So 15 sine of 28 is 7.0. Now 7.0 is less than 9, so that's great. But the 9 is also less than 15. So since the 9 is less than 15, there are actually 2 solutions since it's in that middle section between h and the b value. So we're going to have to go ahead and find 2 separate triangles. Well, how do we do that? Well, we're going to do the first one just like we've done it before. So we're going to go ahead and set up the sine and cosine thing. And then just sine thing, I'm sorry. And then do the second sine here to get 51. Now that 51 is going to be important. We're going to use that to find the other triangle in just a minute. So let's go ahead and finish this first triangle. So you do this, and we got 101, cross multiply, and y equals 18. So there's our first triangle. So now let's talk about the second one. When we did this, we got the 51. But what we do to find the second triangle is we actually take that 180 minus 51. This occurs because the sign is positive in both quadrant 1 and in quadrant 2. So when we do 180 minus that 51 that we got, where did we get the 51 from? We got it from right here. So we did that first step, got the 51, and we continue solving the triangle that way. But once we have that, to find the other triangle, we do 180 minus 51, or 129. Then we go ahead and find the other angle. So 180 minus the 28 and 129 gives us 23. And that 23 then allows us to do law of sines for 7.5. All right, so this one's going to give us 2 solutions. Let's talk about this one here. I didn't show the work there. We'll do another one in just a minute. So here's the sine of 36, and we got to do 9 times the sine of 36, which is 5.29. So 5.29 is less than 6, which is less than the 9. So that means that we're going to have 2 triangles. So this is our beginning values right here. So we're going to go ahead and use that to find our first triangle here and then our second triangle. So to find g, we're going to do sine 36 over 6 equals g over 9. Sine of g equals this. Second sine, g equals 61.8. So then to find h, we go ahead and subtract it from 180, which is 82. And then sine 36 over 6 equals sine 82 over h, cross multiply, and h equals 10. So there's my values for my first triangle. Now what we do with our second triangle is we take this 61 and we subtract it from 180, giving me the 118. And notice that's going to be in an obtuse angle all the time. That's my g value for my second triangle. 180 minus the 118 and the 36 gives us 25, a very different value for h and the 2 different triangles, right? Otherwise, the formula is the same. Sine 36 over 6 equals sine 25.8 over h, and h ends up being 4.4. So doing that, we end up with the 2 different triangles. This one here and this one here, and both are valid. What about this one? We have an obtuse, so we're just looking at our 2 values here, and the L is bigger. So since the L is bigger, we do have 1 solution. So if it's just 1 solution, we just solve it like we normally do. No major issues or problems. So sine 100 over 10 equals sine m over 7. So a second sine gives us 43.6. 180 minus 100 minus the 43 is 36.4. Cross multiply here, and we get 6. And so filling in our chart here is that 43, the 36, and our 6, giving me the triangle. And last but not least, we have acute, so we try our H value, which is 10.7. 9 is less than 10.7, so that means that there's no solution or no triangle. That's what I have for you today.